Hello students, lesson number 4. You're welcome to this audiovisual tutorial on velocity time graph. The audiovisual tutorial is presented by Abdulhafiz Ahmed. Please pay attention as the presentation proceeds. At the end of this audiovisual tutorial presentation on speed, velocity, and acceleration, the student should be able to 1. Define velocity time graph. 2. Derive average velocity from velocity time graph. 3. Derive acceleration from velocity time graph. 4. Derive displacement from velocity time graph. And 5. Work some examples on velocity time graph. To be able to achieve the stated objectives for the lesson, the following content will be discussed. 1. Definition of velocity time graph. 2. Derivation of average velocity from velocity time graph. 3. Derivation of acceleration from velocity time graph. 4. Derivation of displacement from velocity time graph. And 5. Examples on velocity time graph. While listening and watching this tutorial, you may come across some terms. 1. Velocity time graph, which means it's a plot between velocity and time. 2. Displacement, which means the distance traveled in a specified direction. 3. Uniform speed, which means the ratio of S over T, which is constant throughout the journey. 4. Velocity, which is the rate of change of displacement with time. 5. Acceleration, which means the rate of change of velocity with time. 6. Time T, which means the time taken throughout the journey. 7. ms per 1, which is pronounced as meter per second. 8. kmh per 1 is pronounced as kilometer per hour. 9. kmh per 2 is pronounced as kilometer per hour squared. 10. ms per 2 is pronounced as meter per second squared. Now, velocity time graph. Velocity time graph is a plot between velocity and time. It shows the motion of the object that moves in a straight line. The magnitude of velocity at a given instant is equal to its instantaneous speed. It is drawn from one-dimension motion only and can take both positive and negative values. In a case where acceleration is 0, the slope is 0. That is horizontal line. If the acceleration is positive, then the slope is positive. An upward sloping line. Average velocity from velocity time graph. Instantaneous velocity at a given time instant for a particle can be found from the y-intercept of its velocity time graph. For a particle velocity time graph, its average velocity can be found by calculating the total area under the graph and then divide it by the corresponding time interval. Acceleration from velocity time graph. Acceleration of a particle is equal to the slope of the velocity time graph. Acceleration may be positive or negative or 0, and it is a vector quantity. From the figure above, A is equal to V2 minus V1 all over T2 minus T1. In the given graph, A is equal to 40 minus 20 all over 4 minus 2. A is equals to 20 over 2. Therefore, A is equals to 10 meters per second squared. For the displacement from the velocity time graph, displacement of a particle in a given time interval is equal to the total area under the velocity time graph in the given time interval. In a given graph, displacement is found as area of trapezoid ABCD. Note that since displacement is a vector quantity, area below the time axis is considered as negative and above it is considered as positive. Now, velocity time graph for rest, uniform motion, and uniform acceleration. Example 1. A car accelerates uniformly from rest at 3 meters per second squared. Its velocity after a distance of 24 meters is given by dash dash dash. Solution. From the relationship that v squared is equal to u squared plus 2as, v squared is equal to 0 squared plus 2 times 3 times 24. V therefore is equal to root of 144. V is therefore given as 12 meters per second. Assignment. Calculate the escape velocity of a satellite launched from the Earth's surface if the radius of the Earth is 6.4 times 10 to the power of 6 meters. Dear students, in this lesson, we have successfully discussed velocity time graph, which is a plot between velocity and time. It shows the motion of the object that moves in a straight line. 2. Instantaneous velocity at a given instant for a particle can be found from the y-intercept of its velocity time graph. 3. Acceleration of a particle is equal to the slope of a velocity time graph. 4. Displacement of a particle in a given time interval is equal to the total area under the velocity time graph in the given time interval. Having successfully discussed the concepts on velocity time graph, and there are no further questions, let us practice the following questions. 1. What is velocity time graph? 2. How can you derive average velocity from velocity time graph? 3. How can you derive acceleration from velocity time graph? 4. How can you derive displacement from velocity time graph? For further reading on the formulas which we discussed, the following references may be contacted: PNOKK, FNOKK, SLAKANDE, 2011, Macmillan Publishers Limited, current edition. 2. G.O. Eweluka, 2010, Calculation in Physics for Senior Secondary Schools, African First Publishers PLC. 3. O.E. Farinde, H.E.A. Mitela, and S.K. Dada, 2018, Essential Physics for Senior Secondary Schools, Tonard Publishers Limited. 4. Byju's, 2022. Via https://www.toppp.com/ask/content/concept/velocity-time-graph-208251/. we have come to the end of this audiovisual presentation for this week. Meet me same time on the same station next week. I remain your regular presenter, Abdulhafiz Ahmed. Bye for now.